notes to start. The blue paper, before we start that, I want to talk about some navigation. Okay? In navigation, direction is also often referred to as bearing. Direction is bearing. Bearing is measured clockwise from true north. When additional north, south, east, and west information is not given. And so what that means is, clearly, this is true north, right? This is north. And then, for those of you that don't remember west and east, it spells we. So west, east, we. Every right, east and west, you messed up. Okay, so if I say I have bearing of 64 degrees, I'm going to measure that clockwise from true. So this is true north, so it'd be 62 degrees. So this is the 62 degrees. From true. 64, 62, they're all the same. It's from true north, that's the point, right? We're all from true north. So this is how I would measure this. Does that make sense? Okay, so if we did the unit circle, y'all, where did we start our unit circle? That's a problem. From east to north. And so if we're going to adjust from east to north, we'd just add 90 degrees, wouldn't we? Because that would be the first quadrant to true north. Does that make sense? Okay. So bearing can be measured either clockwise or counterclockwise. When additional north-south info is given. So if I'm south 64 degrees east, south 64 degrees east. So if I draw this, here's my north, here's my south, here's my west, and here's my east. So this specifically tells me which way do I start. Right? I'm not going to start up here if it says south. I'm going to start at my south. And then it says to go 64 degrees east. Well, which way is east? Up. So it's not clockwise anymore, is it? Now I move counterclockwise. But that's okay. If you're given specific instructions, you can move counterclockwise. So if I move this way, this would be my 64 degrees. Go south. Directions. So heading is the direction that's direction of the vector. Have any land that kind of looks sideways? The last minute. When it comes in and it comes in, this is the course that the airplane is on. Correct? It's the way it's actually headed. The heading, which when the plane lands is due north, that's the heading. So the wind, they count the wind all the way to the very end, and that's when it snaps forward. Okay? That's the difference between the heading and the course. Does that make sense? Okay? All right. So on your notes from yesterday, so number 7, what? Number 7, 2 ships leave a port. Ship A sails with the bearing of north 68 east at a speed of 17 miles per hour. B sails with the bearing south 35 east at a speed of 12 miles per hour. If the ships maintain paths, how far are they at 2 p.m.? Okay, so first of all, they leave from the same place, right here. Since this is my starting point, this is where I'm going to draw south. Ship A sails with a bearing of north. So this is where it starts. So it's north, and then east is which direction? This way. So this right here is 68. Okay? Now, ship B is going to sail south 35 east. So it still starts here, and then it's 35 east. So which way does it go? This way. So this is 35. And I want to know how far apart are they. This is what we're looking for. So if I know this is a straight line. So 180 means this is 77. So sailed how fast? 17 miles per hour. And how long is that? So I sailed for 6 hours. So these cancel, and when you multiply, that gives me, is it 102? Yeah. So this is 102, the size. And ship B fast, 12 miles per hour. It also sailed for 6 hours. So this side is 72. So yesterday, right? I have 2 sides and the included angle. So I'm going to have x squared equals 72 squared plus 102 squared minus 2, 72, 102, cosine of 77. So on your handy dandy calculator, see if you get what I got. Okay, number 8, not any. The only thing about number 8 that's a little bit different is this time I have 55 degrees and 9 minutes. So remember when we had to change the minutes to degrees? So I take the 9 and I had to divide it by 60, right? So I'm going to do this just to start with. So I'm going to have 55 degrees and 9 minutes. So the 9 divided by 60 is going to give me 0.15. So this is 55.15 degrees. And I'm going to change the 16 degrees and 51 minutes. You have to divide the 51 by 60. So okay. And what if there were seconds? What did I divide by if there were seconds? 3,600, right? So for the minutes, we divide by 60, and for the seconds, we divide by 36. Okay, so here's my degrees that I'm going to use when I draw this now. So we've got two figure skaters, Bruno and Alana. Starting from the same location, so I started them from the same location. So and he's at 55. So if this is my true north, and he's southwest, so this right here is my 55.15. So I went south, and then I went west. So this is the. So Alania skates 18 feet. So that's 18. This is 1685. And she's at south, and she went east. So this right here is my 16.85. So I want to know how far Bruno is. So can I add those together and get that angle? And that one is 72. Now it's side angle side, and that's the law cosine, right? X squared and what do I have to do after I find this answer? I have the x squared. What do I have to do? Square root it, or you get a big answer. But I got 29.024 feet. Give me a thumbs up if that's what you got. Did you later? You, Ruben. I want to see. Last one here, and then we're going to set up the, you better get this answer. No, you didn't. I know. You're a liar. You're a liar. Square root. Erase my Okay. All right, so helicopter. Here's my helicopter. Landing pads below. The straight line distances from the helicopter to the pads. So here's one pad. 14. Here's the other pad, and it's 8. The landing pads are 2 miles apart. Find the angle of depression from the helicopter to landing pad B. So this was A, and this is B, and here's my helicopter. How do I get the angle? If this is my helicopter, there's my line of sight, and this is the down angle. So how am I going to find that? What am I going to do? Do what? Find this angle? So if I get this angle, how do I know this one? Subtract. You're on the right track. Okay, you are. So if I get this angle, the problem with getting this angle is I don't know what is here, right? What? Okay, so sometimes we'll subtract. So we would have to subtract from 90, we would have to have. This time I'm looking for this angle. So this is at the horizon, and this is my line of sight. So these are parallel, aren't they? So this angle would be which angle in this triangle? Would it be right here? Right? Those would be the same angle, correct? This angle and this. So to find this angle, I have all the sides. What do I put by itself on the other side of the equal sign? The 14, and then I can find B. Okay? But the subtract and do exactly what you were telling me to do. Okay? So I'm going to have 14 squared equals 20 squared plus 8 minus 2, 20 times 8 times the cosine of B. Can we solve for cosine of B? Yes, we can, because we are smart. What do you have to use to B this time? So we're going to have 33 degrees. So everybody try that. Wire. All of you are wires. Come back with you. 14 squared minus 20 squared minus 8 squared equals. I've only done 3 things here. And then you have to divide by this amount. This. Divide by, in parentheses, -2 times 20 times 8. Take the inverse cosine of that number. If you don't, all right, we can't do this yesterday. Okay. I'm going to help you. So I'm not going to help you solve them. Okay, fine. You can go to the bathroom now if you want. Okay, Michael leaves home and west to work. After work, he travels 9 miles to a friend's house. If the bearing from work to the friend's house is south 24 east, find the distance between. Well, I don't even need to let you work anymore. First of all of you having so much. Very first line, Michael leaves home and drives 17 miles west to work. This is what I see on your papers. That is not west. Any day, ever. It's not west. Yeah, but does it say southwest? No, it does not. It says he drives west. So here's his home, here's his work, and here's 15 miles. So now where is Michael? Is he at home or is he at work? He's at work. So when he leaves work, which way does he go? He goes to his friend's house. And he goes south 24 east. So wherever Michael is standing, you draw your, because that's how you figure out south 24 east. So south and 24 east, that's this. So here's his handy-dandy friend's house. But the question asks, find the distance between the friend's house and home. So this is what I'm looking for. So if, oh yeah, and there's 9 miles here between, where is it? 9 miles? This one? Okay. I have the angle. So what's left for this angle? I have to add up to what? 90. So this angle is 66. So if I'm looking for this, now I get 9 squared plus 17 squared minus 2 times 9 times 17 times minus 66. And that gives you this amount. Okay, let's try harder to draw number 10. They're 36 feet apart. Truck A, truck B, 36. What are they talking? So one little dot, there's the mower. And what are the 2 tow lines? They're asking for which angle? There's no way to mess this up. It didn't matter if you did this. It's the same thing. Oh my gosh, you guys are exhausting. All right. Number 11. Third time to get this one right. Okay, so the cities of Dallas, Charleston, and Indianapolis make a triangle. The distance from Dallas to Charleston, Charleston to Indianapolis, and Dallas. Dallas and Charleston. So I'm going to start with them. Dallas to Charleston, and that distance is 980. So then that means that Indianapolis is down here. So Charleston to Indianapolis is 595 and 764. So Charleston to Indianapolis. So I'm looking for the bearing from Charleston to Indianapolis. So that means my true north has to go at Charleston. So when I draw that, friends, where is the bearing? This is the bearing, correct? Which angle do I have to find? I have to find C, so I can subtract it from 90, gives me the bearing. Because this is the one I want. Yes. And then subtract the answer from 90. I want the bearing. Does that make sense?